Hello everyone, and welcome to another Zuzin session. How about that? I bet you expect that shit to happen. So let's do a 16th day of Advent of Code in the God's Temple. Here we go. Packet decoder. As you leave the cave and reach open waters, you receive a transmission from the elves back on the ship. The transmission was sent using the buoyancy interchange transmission system, bits, a method of packing numeric expressions into binary sequence. Your submarine computer has saved this transmission in hexadecimal. Okay, I know what is a hexadecimal. Your puzzle input. The first step of decoding the message is to convert the hexadecimal representations into binary. Each character of the hexadecimal corresponds to 4 bits in a binary data. Okay, cool. The bits transmission contains a single packet at its outermost layer, which itself contains many other packets. The hexadecimal representation of this packet might encode a few extra zeros at the end. These are not part of the transmission and should be ignored. So it's kind of like a simulating whatever is going on in the networks, right? So you have like Ethernet packets, within them you have like IP, within the IP you have like UDP or TCP, and so on and so forth, right? So I guess maybe that's what's going on, but I'm not sure. I still it's kind of difficult for me to comprehend these problems. So every packet begins with a standard header. The first 3 bits encode the packet version, and the next 3 bits encode the packet type ID. These 2 values are numbers. All numbers encoded in any packets are represented as binary with the most significant bit first. Most significant bit first. Okay, for example, a version encoded as a binary sequence 100 represents the number 4. Okay. Packets with the type ID 4 represent a literal value. Literal value packets encode a single binary number. To do this, the binary number is padded with leading 0 until its length is multiple of 4 bits, and then it is broken into groups of 4 bits. Each group is prefixed with a 1 bit, except the last group, which is prefixed by a 0 bit. These groups of 5 bits immediately follow the packet header. For example, the hexadecimal string becomes I didn't understand shit. Thank you so much. What? Okay, so below each bit is a label indicating its part. Okay, so here we have a package. For example, the hexadecimal string becomes this. All right, so and this is the version. This is the type. Bits start with 1 and not the last group pick reading, and contains the first 4 bits of the number. Okay, so these are 4 bits of the number. The 5 bits labeled B start with 1, not the last group. And okay, so it kind of reminds me UTF-8, right? So yeah, so they're basically chained together. The 3 unlabeled 0 bits at the end are extra due to the hexadecimal representations and should be ignored. Okay, so this packet represents a literal value with a binary representation, right, which is 2021 in decimal. Okay, that's cool. That is very, very cool. Every other type of packet, any packet with a type ID other than 4 represents an operator that performs some calculation on one or more subpacket contained within. Okay. Right now, the specific operations aren't important. Focus on parsing the hierarchy of subpackets. An operator packet contains 1 or more packets. To indicate which subsequent binary data represents its subpacket, an operator packet can use one of 2 modes indicating by the bit immediately after the packet header. This is called the length type ID. Okay. If the length type ID is 0, then the next 15 bits are number that represents the total length in bits of the subpacket contained by this, if the type blah blah blah. Finally, after the length of type ID, bit 15 subpacket. For example, here is an operator packet, hexadecimal blah blah blah, with the length type 0. With the length type ID 0 that contains 2 subpackets. Okay, so here's the version, here is the type. Version and type. Bit labeled I is the length type ID, which indicates that the length is 15 bits number representing the number of bits in a subpacket. The 15 bits label, I feel like I'm reading RFC, to be fair. That's what it feels like. The whole problem just feels like reading RFC of some sort, right? So you can just like take any RFC and use it as an advent of code challenge, all right? So just implement that RFC, implement the parser for that thing. It's just like it's getting ridiculous at this point. I don't know. So, all right. So I is the length type ID, which indicates that the length is 15-bit number representing the number of bits in a subpacket. The 15 bits labeled L contains the length of the subpacket in its bits 27. The 11 bits labeled A contain the first subpacket, a literal value representing the number 10. The 16 bits labeled B contains the second subpacket, a literal value representing the number 20. Okay, so I guess cool. After reading 11 and 60 bits of subpacket data, the total length indicated in L27 is reached, and so parsing of this packet stops. As another example, here's an operator packet hexadecimal string with length type ID 1 that contains 3 subpackets, and so on. Like, it's just unbearable to read, holy shit. After reading 3 complete subpackets, the number of subpackets indicated in L is reached, so parsing of this stops. Okay, so I see. Cool. For now, parse the hierarchy of the packets throughout the transmission and add up all of the version numbers. Okay. Here are a few more examples of hexadecimal encoding transmissions. All right. Blah, blah, blah. Cool. So a operator packet that contains the operator packet that's okay. Decode the structure of the hexadecimal encoded bit transmission. What do you get if you add up the version numbers in all packets? Okay, so this is the sample, right? Okay, so this is the single sample, and the input here is this thing. Oh, okay, so you just like have like a single huge thing and you need to parse it, and this is basically hierarchy and stuff like that. Cool. So it is relatively straightforward to actually read this input, because TempleOS can just read the whole file, and that's basically it. And I think we're gonna start with implementing like a simple function that can just parse the ith bit of this entire thing. So let's go ahead and actually start a new day. Run, actually new day. So it's going to be day 16. I need to provide the image of AoC. So it will mount everything. So in terms of the samples, I'm not sure what we're going to put in the samples. So I think I'm going to just like quit this entire thing, but I'm going to add the actual input that I have in here. Okay. So here is the actual input, and I'm going to save this entire thing, and I'm going to quit it. So let's actually run AoC 2021. So drive C. So 16. Cool. So we have a part 1, and after we read like the entire thing, do we really even need anything in here? So I suppose we don't even need SV or anything like that, because now I can do something like this, right? So this is the packet, right? So this is the packet. And then we can have something like a size, packet size, which I'm going to put in here. Packet SZ, so we don't need that, and there we go. Well, what's interesting is that, what the hell is going on in here? Blinking. I accidentally pressed something and it inserted blinking for some reason. So it probably contains like a new line at the end, right? So I kind of want to confirm that. Because of the way I read the entire thing. So I'm gonna do it like this. So this is gonna be D, new line, packet SZ -1. So what is the last value? The last value, as you can see, is 10. I hope I can zoom in here, but it's kind of, yeah, there we go. Cool. So it is in fact 10. So that means after I read everything, I want to do packet SZ -1, or maybe just minus to remove last new line from file, right? So this is what we want to have. So the first thing I want to do probably is being able to take ith bit of the entire packet, right? So essentially I want to have a function I want to have a function, something like get bit, and it will accept the packet and the size. Right, so this is going to be the packet. Maybe I'm going to just call it P. So here's the packet, and then i64 size. And which one do you want to read in there? Right, which one? To be fair, it feels like I'm passing SV, but I'm going to pass that explicitly. So I'm going to do i64i. Right, so once we get this thing, we should be able to, to be able to parse this thing quite easily. So, all right, so each character within this entire thing represents 4 bits. Right. So if you have like A, F, B, E, and so on and so forth, A is 4 bits. So, but I points at ith bit. Right. First thing we need to do, we need to figure out. So you can treat each character as sort of bucket of 4 bits. We need to first figure out which bucket I points to. Right. And the bucket it points to is basically I divided by 4, the size of the bucket. So that way we can grab the exact byte I out of the packet thingy. Though we have to be a little bit careful in here, right? If this entire thing overflows the size, we have to sort of like indicate that. We have to say something, otherwise we're gonna miss the bug. All right, so I can do something like i64, so let's call it j, which is i4, and I want to make sure that j is less than the whole size. If it's equal or greater than size, that means we actually trying to access something outside. Right. So what we're gonna say in here, so this is gonna be pj, and in here we're gonna do something like get bit overflow, right? Something like overflow. All right, so once we've got this thing, we need to figure out which bit do we have to take. Right, so we have a number of these sort of bits, and if we need to take the first one, we actually have to take this one. Right, so the bit within the bucket is essentially i64k equal to I mod 4, right? So, and in here, that means we move that thing how? So if it's 0, we have to move it by 4. All right. So that means I'm going to do 4 minus k. That's actually not 4, 3. And then after that, I need to do 1. Right, and then I can safely return this entire thing. So if it's going to be 2, I actually will have to move it by, so by 2, I think. Right, if it's going to be 1, I think it is correct. So 0 is going to be this one because we move it by 3. 1 is going to be this one because we're going to move it like 2 times. And if it is the third one, we're not going to move it, we're going to just extract that one. Okay, so that's cool. So that's the entire function that will parse everything, and we're going to use that. Right. It would be nice to actually print this entire thing. So let me see how we can do that. Let's do u0 print bits. We're gonna accept the packet and then the size of the packet. Right, the size of the packet, and we're gonna essentially just print each individual bit of that thing. Let's allocate this thing. So I equals 0, I less than sz multiplied by 4 because there's 4 bits in here. And then in here, we're going to do the following thing. We're going to do d get bit psz I, right, and then we're going to put this thing in here. Cool. So print bits, we're going to provide something like f, and the size of this entire thing is going to be 1. So we're going to try to run it. It did not compile because packet. Okay, so unused variable packet in here, which is kind of, well, I mean, it's fine. It printed What the hell is going on? What the hell is going on? 0, 1, 1, 0, which is not correct, right? Because I actually... What the hell is going on? One more time. Okay. So, which is not correct, because I would expect this thing to be 1, 1, 1, 1. So something went horribly wrong. It's not 0, 1, 1, 0, that's for sure. So the question is, what the hell is going on? Seriously. Okay. That is really, really strange. Are you sure about that, buddy? This is really freaking strange. Okay, so if it's going to be 1, we're going to be iterating through this entire thing. And this is the k. Where did I make a mistake? Where did I make a mistake? Let me actually just sip a cup of tea. So this is really weird. So what if I try to print the character? Every time I get that character, I want to print that character just to see if I'm picking the right one. So, okay, so it was always FFF, I'm always picking the right one. So, and in here, I feel like I'm not sure. So if I just do that, it is also not correct. So 3 minus, again, 1, 4, right? So this is 1, 4. If I'm at 0, how many times do I have to shift to the right? I have to shift 3 times, right? So that means it's going to be 3 minus 0. This is how many times I have to shift, right? If I have 1, I have to shift 2 times, right? So 3 minus 1 is going to be 2. So I'm shifting 2 times and then I'm grabbing like 1 out of that. So I don't see why it would be like that. It should return something reasonable. Is that because I'm not using I64? Don't tell me that this is because I'm not using... Well, it's probably not because of that. That would be absolutely stupid. So what is going on? Why? Why? I don't understand. Oh boy. I think I'm going crazy. So if I do get bits, right, get bit out of f, right, out of f, and I'm taking the zeros one, right, I'm taking the zeros one, and I just want to print this thing. So I'm probably made some sort of like a very stupid mistake in here. So this one has to be 1. So this is 0, which is not. I know what is going on. I forgot to convert it to the actual number, so I have to convert f to... Okay, I'm an idiot. So yeah, I completely forgot about that. So essentially what we have to do... Oh man. We have to... Yeah. Hex to dec. I'm really getting nervous. Right, I'm starting to make this kind of mistakes when I'm getting nervous, so I'm really sorry. Right, so this is one of the reasons why I stopped streaming, because I get really nervous, I make such mistakes, and chat is usually going crazy and start blaming me. Okay, so just a second. Let me see. If this thing is within this stuff, right, this is going to be like that. Right, and that means I can just return x minus 0, right? So, and we're gonna assume probably that there will be no like small letters, but I'm gonna do that just in case, right? So this is gonna be a less than that, and it's gonna be f, and in here x is gonna be something like a, but this one is gonna be plus 10, and if a less or equal than x, then f, all right, then we're gonna return x minus f plus 10, and hex to dec unreachable. So this is gonna be the new line. There we go. So this is how we're gonna do in here, and hopefully after that, when I try to print this entire thing, print bits F1, right? So I'm gonna try to do that. It's 1010, which is still incorrect, by the way. Which is still incorrect, so that means I made some sort of a stupid mistake in here, which is obvious. This time it's 111, finally. Right, so yeah. Okay. Oh boy. So let's actually try to see some of the... This is not what I wanted. Really, this is not what I wanted. So let's take a look at some of the existing examples in here. Like, for instance, this one. Right. I still didn't fully understand what the fuck it wants from me, because it feels like reading RFC. It's just like so painful. Okay. So this is the version. I might try to confirm that this is what it is, right? The 3 bits label T or packet type ID. Does version even do anything? Because I don't remember, like, my brain actually completely zones out when I read this sort of text, so I don't really remember. Does version even mean anything? Does it not mean anything? It's just like, holy shit. Anyway. So let's try to maybe parse the version. Right, so parse the version. So let's call it something like i64 version. Right, so in here we're gonna accept the packet, right? So it's gonna be i64sc, and the version is how many bits? 4 bits, right? So it is 3 bits. All right, that's cool. It would be also nice if we could chop a version out of the packet. So which also brings us to the point that maybe I should use string view that I use throughout my entire thing, right? So because I developed a string view at some point, which is basically a structure, size and the beginning of the string, and I use it for parsing. So maybe we can use that thing for, you know, parsing the packets as well. Or maybe not, actually, because... yeah, we need to keep track of the size in bits rather than the size in... oh, okay, so maybe we'll have to come up with a slightly different. So it's more of a like a bit view rather than the string view. Not bad, actually, if you think about that, right? So it's a bit view. And if you want to chop a certain amount of characters, so it's going to represent a particular... yeah, I can see that. So we can store essentially the whole string, then the size of that string, and then two additional numbers, the beginning, the bit beginning, and the size of the bits left within that string that we're storing. Something like that. So, and that way we'll be able to like sort of chop this entire thing, hopefully. We'll see. We'll see the winner gets T. So the idea that I have, I'm not sure if it's gonna like work out or anything, so it's gonna be bit view, right? And within that bit view, we store the string, so this is going to be SV, and then we're going to have i64 start. It's already taken, Terry. Why would you take that thing? Begin. Okay, cool. And i64 size. I don't know what start mean actually, so maybe it has like meaning of some sort. So yeah. And size is basically in bits, not in characters. It's more of a in bits. Though maybe it would be better to actually convert all of that to like a sequence of bits, so it's a little bit easier to parse. But maybe, I don't know. So maybe it's better to like put some sort of abstraction over it. Put some sort of abstraction over it. Let me see. So yeah. So I think I want to make a small break to refill my cup of tea, because I cannot really think without my cup of tea. So I decided to go with just water. I think I'm kind of overcomplicating everything. So what if I just had like a very simple function, I suppose, that basically converts everything into array of bits of some sort, right? So like convert, and it would accept the packet, right? So the packet and the packet size, and then the pointer to the bits, right? So, and the size of the bits is basically PSZ, but multiplied by 4, right? And we can pre-allocate that thing quite easily. So yeah, and then if we want to parse everything, we're gonna just parse that array, so I don't have to deal with the complexity of what I'm trying to do in here. Right, so I think I'm kind of like overthinking this entire thing, so let's actually make it as dumb as possible. Okay, so this one is not going to really return anything, right? And let's do the following thing. I64I for I0, I less PSZ plus I, right? And I also probably wanna keep track of how much we already filled bits, but I don't think it's that necessary. All right, so this is going to be j, and within the j we're iterating 4 plus j. There we go, there we go. Okay, so and for this entire thing, we're going to take this single character, right? We're taking a single character I. We're taking a single character I, and we are shifting it, right? So we're gonna do shift to the right. I'm trying to find the code that okay, so here's the code. 3 minus j, so we're shifting like that, and here is the bit, right? Here is the bit that we have to put into the bits, right? But the index within the bits is going to be essentially I multiplied by 4 plus j, and that's it. So that doesn't even require any curly braces if you think about that. So it's as simple as that. So it's just like two-dimensional array, and there we go. So the size of the actual input in here, right? So we can just pre-allocate like a huge array of bits for this entire stuff, right? So here is the thing, and if I take a look at it, it's basically, we can pre-allocate like 2 kilobytes of characters for this entire stuff. Shouldn't be that hard to do. So, and in here we just convert this entire thing, but I was thinking maybe I can just use SV, but it doesn't matter. Okay. So, and let's pre-allocate some bits. U8, I'm going to define bits capacity, and as already said, we're going to have 2 kilobytes in here. 48, and this one is going to be basically bits capacity. Cool. We read this entire thing, and what I just do, I convert my packet SZ, so it's already subtracted, and then bits. And the amount of bits in here, let's actually have something like bits CNT. The amount of bits is going to be bits CNT equal packet size multiplied by 4, right? So that's basically what we have in here. And yeah, so we can just print bits. So we probably don't, and I made the same mistake yet again, by the way. I made the same mistake yet again. I forgot to do hex to dec, of course. I forgot to do this thing. All right, so I'm gonna now remove this stuff. So get bits is not needed in here, right? So, and I guess that's it. So this is the, and even the amount of code is actually became smaller, right? So, but I still want to have a way to dump those bits, right? So let's actually do something like U0 print bits, and let's just take a look at them. So I64I for I0, I less than bits CNT plus I, and we're gonna just basically print that value, bits I. So, and then do I need to return anything? I probably want to put like a new line in here, right? So, but before I can do all of that, so maybe I need to have some sort of a sample, right? I think I can have that. If I do ed sample txt, right, so I can put f in here and boom. And the thing I hate the most, TempleOS probably put an extra character in there, so this is really, really painful. Okay, so I'm constantly worried about like extra characters in my input, and I think the easiest way to avoid that would be to still use the string view, right? So I'm gonna do SV like that, right? And then I'm gonna actually allocate another one for the packet, right? So, and then I can do SV begin. This is gonna be SV size. This is SV size. I can remove that, and I don't have to worry about that. Okay, so I have SV, which I'm gonna do SV chop by delimiter, right? So I'm chopping that one. The delimiter is a new line. And then I'm chopping that into the packet. So if I have a new line and something after the new line, it doesn't matter. It's going to be chopped off anyways. So I don't have to worry about that finally. Okay, and then here I can just do packet begin, packet size. Or maybe I can just like make it finally accept the string view, and that should be it, hopefully. All right, so here we are converting this entire thing. So but that will require like to change a lot of things in here, but maybe it's worth it. Maybe it's worth it. So we're going to do SV P, right? So we're iterating through P size, PP size, and this one is going to be P begin, right? So this is the P begin. Cool. All right, so we converted everything. So I'm going through the sample. Let me try to run that. And of course, we have a couple of unused variables. But what's important is the error, right? So what's the error we have in here? So beats, I don't know what you want, invalid member begin, and this is because this thing has to be like this. Invalid L value at BTS count, BTS count. I didn't see BTS count. Where did you see BTS count? Right, where is it? Bits. Okay, cool. Another error, it's 47, and okay, so this one is essentially P size. Okay, so there's a couple of warnings in here at 18. Version, we're not going there yet. And now finally it works, but another thing I want to do, I want to print the bits. Right, so it's 111, which is cool. So in a sample, I can put something like AF, right, and then just run it. So here we go, here we have that thing. Cool. So, and now we probably want to have something interesting. So we have a bits count. And maybe we're also going to keep track of how much we already parsed, right? So bits begin, right? So bits begin, something like that. Bits begin equal to, this one is rather interesting if you think about it. Because you can now wrap these bits into string view, and you can chop certain amount of bits and convert them to a number. This is a very interesting idea, right? This is a very interesting idea. So this one is basically hex to bits, hex to binary. Yeah, that's very cool. So what I mean is basically have a function I64. I don't know how to call that function yet, so let's call it foo. So, and it accepts the bits somehow, right? So this is basically the bits and the amount of bits that you want to chop, right? So let's call it like n. And what essentially it does, it chops n amount of bits and converts them into a number for you automatically, removing that from the string view, and we can use these bits as the back buffer for that string view, right? So, but I need to come up with better names for all of that, right? So I need to come up with better names. So convert, so maybe I'm gonna just query replace one thing, convert. So this one is basically hex string, hex str to bits, Right, and we're going to replacing all of that, and let's go. So convert it, but it converted only one because I actually started from here. So let's also replace this one, hex str 2 bits. And in here, we can do something like chop bits, or maybe bits chop, because we already have things like sv chop left and so on and so forth. So maybe because of that, we're going to want to call something like a bits chop left. Right. So I think that's a pretty cool idea, because now what I can do is allocate some sort of a chunk in here and do sv chop left, right? Sv chop left. I provide the bits and I chop them into this chunk. Chop left does not return this thing, but we don't really have to do that anyway. Right, so yeah, so this is basically what we'll have to do. We'll have to do for, so where's I64? I64, 0, right, I64, 0. And so what we're gonna do, 0 n plus plus I, and maybe we're gonna have some sort of a result in here. Right, so and essentially what's going on is result equal result shift to the left, it is shift to the left, and then or bits begin I think, bits begin I. So we're basically collecting all of that into the result, and then we're chopping off this and bits out of that string, and we're just basically returning the result, right? So then you can say, okay, chop 4 bits out of that thing, and it will do that and automatically return you the number represented by those strings. So, and then based on that number, you can do dispatching, whether it's one type, you want to do one thing, whether it's another type, you want to do another thing, and so on and so forth. So yeah, it's relatively convenient, I think. I do think so. Cool. So, and then we print bits. In this particular case, I think, yeah. So I want to call this thing not bits, but it's more of a bits buffer, if that makes any sense, right? So it's basically like a back buffer for all of the string views that we're gonna have in here, and that kind of eliminates the need for these variables, because all of that is going to be tracked by the string view. So let's call it bits buff. I might as well Control F this entire thing. So bits capacity is going to be replaced with bits buff capacity. Right, so we're replacing that. We had to actually start from here, I think. There we go. And this one also should be called bits buff. So, and print bits should now accept this thing like so. So now we can just do quite easily bits size, and then this one is going to be bits begin. Cool. That is very cool. So we're reading this entire thing into the packets, and we're converting them into the bits buffer. So we have a bits buffer, but we need to now construct the string view for the bits, right? So that means here we're gonna have the following stuff. Bits begin is gonna be bits buffer, and bit size is going to be the size of the packet, right? The size of the packet multiplied by 4. So here is the bits. So if I pass it by a pointer in here, is it gonna work? So it had a chunk, but it's not needed anymore as far as I can tell, right? So it is not needed anymore. And the result is more or less correct if I understand it correctly, of course. So let's put FOF in here, and if I try to run it, so it is looking very nice, very nice. So that is very cool. So here is the buffer into which we're actually allocating everything. Right, so, and the reason why we're pre-allocating this buffer, so we don't have to worry about memory management. Right, if you don't want to worry about memory management and you have like a very specific limitations, right, on the input side, you can just pre-allocate some stuff and you don't have to worry about that. Not suggesting that in a production and especially in security important applications, but generally if you want to get some shit done, you don't need malloc or anything like that. Just pre-allocate like things. Okay, so we can do bits chop left, bits chop left. So let's give it a try. Let's give it a try. I want to take a look. I need to unselect this thing so I don't accidentally drag it around. Okay, cool. So let's take a look at this thing, at this example, right? So let me see if we even parsing this sample correctly, right? Because I'm not sure. So I was trying to copy paste this thing. I just realized that I have no way to easily copy paste that. Okay, D2 FE28, right? So hopefully that will represent something that makes sense. Okay, 1 1 0, and then there is 3 zeros at the end. This is more or less correct. So okay, we printed those bits. One of the things we can do now, we can chop, rather bits chop left. We provide those bits and we say that the amount of bits we have to chop is 3, right? So we have to chop 3 bits out of that. Tempo OS is just like pisses me off. Okay, 3 bits. Okay, so this is the version. My God. Oh. So version D. Version. Okay, version is 6. The next thing, we need to take a look at the type. So we might as well do the following thing: I64 type, bits chop left, bits 3, right? Another 3 bits, and so then we want to actually print that information. So this is going to be type. So let's pad everything. Let's pad everything, and this is going to be the type. Okay, so version 6 type 4, right? Version 6 type 4. So below each bit, all right, the bits, the 5 bits labeled A. The packet with the type 4 represent a literal value. Literal value packets encode a single binary number. So, and essentially we can write a separate routine that can chop off this like variable amount of things, right? So let's go ahead and write that. So let me see. Let's call it something like bits chop literal, right? So we can call it like that, bits chop literal. And we're gonna accept the bits, of course. It's gonna be SV bits, and that's it, right? So I think that is basically it, because we're gonna stop when we have the last chunk, if that makes any sense, right? We're gonna stop when we have the last chunk. So, and there's 2 conditions when we stop. So the chunk is the size 5, right? Chunk is the size 5. Though we can always chop by 1 character in here, right? Yeah. While bits size is greater than 0, we wanna do something like I don't know, I64. Let's call it C, right? And that C is going to be equal to essentially C equal bits chop left. We provide the bits and wanna actually do this thing, right? Then we take the number, right? We take the number I64 n. So might as well actually maybe put it in here. Then it's going to be n. Bits chop left bits 4, right? And I suppose we'll see. So I don't know how I'm gonna actually reconstruct this entire thing, but we'll see how it will go. Okay, so and essentially I'm gonna do results moved by 4. I think that's the safest way to deconstruct this entire thing. And then I'm gonna OR it with n, right? So I'm ORing that with n. Should have actually called it bits. And then, depending on what we have in C, we're gonna either continue or not. So I suppose we continue as long as it's 1, right? As long as it's 1. So one of the things we can do in here is maybe while C is greater than 0, right? And I'm gonna just literally assign 1 to here. Right, so we have some stuff in the bits and C is greater than 0. We chop everything in here, add it to the result, and then on the next iteration, if it is continue, we're gonna do that. So that's looks all right, more or less. And then we're gonna return the final result that we have in here. So here we're gonna have the following thing. I64 literal, right? Bits chop literal, and in here I'm gonna provide the bits, and I don't have to provide anything else, right? And this one is gonna be literal D and literal boom. Okay, 2021. Okay, so we successfully parsed this literal binary packet, which is rather interesting because, yeah, can I now wrap that into a separate function? I think I already did. So that should be fine. Cool. Now, every other packet type, any packet with the type ID other than 4 represents an operator that performs some calculation on one or more subpackets. So I suppose the actual thing in here is basically an AST, right? Where you have an operator tree of operators and then the values at the leaves, and you just have to recursively iterate all of that and just like, you know, compute this entire thing. All right, so cool. So you have a particular version which you probably want to skip. Right, 3 bits labeled version 1, 3 bits labeled type, which means the packet is an operator. The bit label I is the length type ID, which indicates that the length is 15-bit number representing the number of bits in a subpacket. The subpacket in bits. Okay. So okay, it contains the first labeled I is the length type ID, which indicates that the length is 15 bits number representing the number of bits in a subpacket. The 15 bits label contains the length of the subpacket. 27, the 11 bits A contains the first subpacket, a literal value representing 10. The 16 bit contains the second subpacket. Still don't quite understand. Right. So I suppose one of the things we can do in here is probably traverse the subpacket. So I need to restart my thing because... Okay, so let's do something like this. Traverse packet. Maybe just call it traverse, right? So this is going to be SV bits, right? We want to traverse this entire thing. So also maybe we want to keep track of the depth. All right, so we can render all of that properly. Depth is originally going to be 0, so it's rather convenient. And let me put everything in here. Okay. So this is the version, the type, and then this is the literal. So what I want to do is probably depending on the type, right? If type is equal to 4, right? So because the type for the literal is 4, right? So that means I can just like print this entire thing. So there we go. And I'm thinking that, yeah, let's do it like this. So here I'll have to use the depth, maybe multiply by 2, then the empty string. So this is going to be our poor man's padding. And then in here, I'm going to say literal, and I'm going to provide the value, right? And the value is going to be the literal value. Okay, cool. So it only makes sense to do this thing. Man. Undo thing in TempleOS is unbearable. It is absolutely unbearable because it collapses way too many actions, right, into a single action. When you do undo, it may remove half of your document. It's just like, it's so unbearable. Don't use it. Don't do undo in the TempleOS. It's just like horrible. So literally, the thing I wanted to do is just like move this thing in here, so then I can do something like that. Right, so here is the literal, but maybe it doesn't matter. Maybe I don't even have to allocate this entire thing. Right. The pain. Okay, cool. It's really difficult to refactor anything in this editor. Anyway, so the operator, hater. So we already have a type and the rest of the stuff. I still don't understand. So the bit label, maybe I need to read about that stuff. The operator, so every other is operator. Operator packet contains one or more packets to indicate which subsequent binary data represents its subpacket. An operator packet can use one of two modes indicated by the bit immediately after the packet header. This is called length type ID. If the length type ID is 0, then the next 15 bits are a number that represents total length in bits of the subpacket contained in this packet. Okay. If the length type is 1, then the next 11 bits are a number that represents the number of subpacket immediately contained by this packet. Ooh, I don't understand. The number of subpackets. The length type 15 is that represents total length in bits of the subpackets contained by this packet. If the length is 1, then the next 11 bits are the number that represents the number of subpackets. So yeah, but why would you do it like that? That's really weird. So the total thing, the total in bits, and then the number of subpackets. Why? Okay, that's really weird. I don't understand. So the bit label I is indicates that the next represents the, okay. So the 15 label contain the length of the subpacket in bits, and the 11 bits contain, okay. Okay, and together they form 27, so they come after each other. So it's just like a different way to indicate the length of the subpackets. Right, so that's basically what it is, isn't it? I think, probably. I'm not freaking sure, but it's just like so weird. Like, okay, after reading 11 and 16 bits, the total length indicated L is reached, and so parsing of this packet stop. As another example, here's the operator packet with the length type 1. So the 3 bits blah 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 1. So that means it contains number of subpackets 3. So the 11 bits contains first subpacket, a literal one representing number 1, 2, 3. After reading 3 complete subpackets, the number of subpackets in. Okay, so that's 3 different equivalent modes, right? It's 2 different equivalent modes. They don't really have any advantage over each other. It's just like, yeah, it's just like extra challenge, like artificial challenge for you. Just implement 2 different modes. There's no point in having them, but you have to do that because it's a challenge. All right, so. So for now, parse the hierarchy of the packets throughout the transmission and add up all of the version numbers. Okay, after an hour, I finally understood what the fuck the problem was for me. I'm sorry, I'm dumb. What can I say? I'm just that dumb. Okay, so let me see. So we're gonna have I64. We're gonna have a mode, right? So this is the mode, and the mode is indicated by. So, oh, by the way, this is freaking dangerous. Thank you, Terry. Very cool, because it's already a pointer, right? And the compiler won't even tell me. That's what's interesting, is that the compiler won't even tell me. Bits, this is going to be bits. And I need to do that one, right? If the mode equal to 0, we're going to have one thing, right? So, and I'm gonna have another thing. So in here, right, we're gonna have n, and that means n. So in case of 0, in case of 0, in case of 0, in case of 0, Where am I? It's so difficult for me to comprehend what the fuck is going on. Okay, so 15 bits, okay, because I don't remember that by heart. 15 bits chop left, bits 15. Right, so this is that mode. And in here we have bits chop left. Okay, 11 bits. Okay, so it's gonna be bits 11. So this is basically traversal. This one is rather interesting. We can try to indicate. So I think this one has to be called something like bits chop packet, right? So this is a bits chop packet, and I feel like it must return the amount of bits it already chopped, right? So then we can use that information to know when to stop and so on and so forth. Bits chop packet, right. Interestingly enough, we may maintain the count, right? So initially it is 0. When we are chopping this thing, we also adding how much we chopped, right? So maybe I can do something like this, right? So I have a version and then count plus equal 3. So in here, bits chop literal, we chop the literal, but we don't really know how many of these things we chopped. Unless we can modify bits chop literal to accept that count and increment that count for you. That is very interesting. So let me quickly do that. So this is going to be i64 count, right? And in here, every time we chop something, we're going to do count ++1, count ++4. So it is also very interesting. It is very error prone in some sense, because if you change the amount of bits you chop, you have to change that in 2 places in here. What I'm thinking is that maybe bits chop left should also, why do I have this thing in here? TempleOS. It should also accept the amount of things in here, right? So this is going to be something like count. This is very interesting, I think. So essentially it's going to be count plus end. So this is how many we chopped from this entire thing. And by doing so, we don't need to do that stuff anymore. So you're kind of forced to provide the count to know how many things you already chopped. Right, so there we go. So this is the count. All right. And in here, we also don't have to do that. So this one is going to be the count, which also brings us to a very interesting point. What if we're also going to accept the count in here? So I still don't have a use for the depth yet. I was hoping that it's going to like help me to maybe print all of that in a hierarchical way. But I'm going to put that at the end. Right, so it's going to be i64 depth equals 0 just in case, right, and don't have to have this thing in here. So basically just pass that count everywhere all the time, and you're not going to have any problems, hopefully. We'll see. So here's the count, and it automatically returns everything for you. So here you don't have to return anything. If you're interested in this thing, you may provide it. Though here is the thing we can do. We can put null in here, right? You can put null in here, and if you're, well, if I put null in here, I will encourage not to provide it, so let's actually put it in here, because you always have to provide it. So I was thinking that maybe if you mark it as null, it will not count it for you, so if you're not interested, don't provide it, but let's always provide it just in case. Because who knows, right? So yeah, we want to count everything. So we provide the count, here is another count, and if you chop left, you also have to provide the count, and here you also have to provide the count, so we always keep track of how many of these things we read. We always know, Okay, guys, so that's very POG, isn't it? I think it is. Okay, mod 0 indicates the amount of bits, right? Mod 0 indicates the amount of bits. So that means, I need to know something more than that. So let me allocate like an extra thing in here, something like m, right? And then after that, I'm going to do bits chop packet. We can even have some sort of a loop. While n is greater than 0, right? We're going to do bits chop packet. We provide the bits, but we provide not the count. We provide our m, right? We provide our m and maybe depth +1, right? So after that, we are subtracting m from n, right? And also incrementing the count, right? Plus m as well, right? So that way we'll know when to stop. Right, cool. So in here we have a slightly different situation. We also do it like while it's greater than 0, but instead of subtracting m, we're going to be subtracting 1. And now we don't even have to keep track of n because of that. So we can just straight up provide the count then, right? So this is just a count. There we go. So yeah, cool. That's basically it. I would say, I do think so. Cool. So, and what we want to do, we want to add up all of the versions, right? So we want to iterate through all of that and add up all of the versions. So far, so good. Let me actually see if this entire thing compiles, because I haven't compiled this thing for quite some time, so it probably doesn't compile, of course. So here's the version, and what you don't like about this stuff, please tell me. Missing expression at blah blah blah. Bits chop. Did I just remove something important? I think I did. So this has to be 3. How did I remove that? So it is 3 and 3. Okay, 3 and 3. Unused variable version in bits chop packet. This is not true, right? Or is it? And why do you point at a completely incorrect place? 85. I really hope that it's 85. But like, why do you point in here? It's so useless. Okay. Version. How are we gonna be doing all that? That's very interesting. Anyway, so let me see. What's the point? What do you get if you add all the version numbers of all packets? So maybe we're gonna actually like accept this thing through I64, right? So I64, and the version in case of the literal, right? In case of the literal is gonna be like this. So this is the version. We just return the version. So then we chop the packet, and in here we can just like, yeah, I have an idea. What if I simply do it like this? I'm gonna return the version, right? I'm gonna return the version, and in here we're gonna do version plus, right? Version plus. Cool. We never actually called that thing, but that's fine. I64 count, right? And I want to actually initialize that thing with 0 just in case, because I think it's useful. Part 1 D bits chop packet. Provide the bits, provide the count, don't have to provide the depth, and it didn't print anything for me for whatever freaking reason. Thank you very much. because I never actually called part 1, of course. Of course. So, okay, literal 2021, part 1 is 6. Okay, that makes sense. So let's actually take a look at some of the examples in here. Represents an operator packet version 4. Okay, so maybe, you know what? Let's actually go and add all of these things into the sample, right? And the way I'm going to do that is that we're going to iterate through all of the lines, and for each line we're going to do the conversion and stuff like that. So I think this is the good way to test this entire thing. All right, so let me see. I'm going to mount AoC. Where am I? Setting and AoC 2021 MNT home 16. Sample, I think this is going to be that. So here is this. Okay. And this thing. Cool. So hopefully I didn't miss anything. Now I'm going to probably close this stuff and run my AoC. So 16, cool. 16. So we have SV, we have beats and stuff like that. While SV size is greater than 0, we are chopping the packet by delimiter, right? Chopping the packet by delimiter and just doing this entire stuff. But for now, I just want to see if I'm reading everything correctly in here. Also, I want to make sure that it's actually greater than 1, so I don't have to worry about the... whatever. Okay, so let me see. Print SV P. Okay, so we're looking at the sample. Unused variable beats, and of course I forgot to put a new line at the end of the print SV. Right, so something like this. And here are all of them. Cool. So, and now in here I convert everything into beats buffer, so then I create a new beats, and then I do this entire thing. Okay! Cool. Stack Overflow. All right, so that's actually very cool. So if you have a Stack Overflow, it's going to actually crash your entire operating system. Finally, we managed to crash TempleOS. This is so cool. I think it requires a little bit of a celebration, and I need to make a cup of tea. So, all right, I forgot to unmute myself. So, I think I know what could be a problem. So let me restart the entire TempleOS and just see. So 16, let me take a look. Of course, I never actually zeroed out M. Right, so yeah, that's a very huge mistake. First of all, it's not initialized at all, so it already contains garbage. And then I meant to initialize it with 0, so I know how much I sort of chopped off from the packet. So that's what I meant. And it still crashes, so that was not a mistake. Okay, I really like every time I Stack Overflow, I have to restart the whole operating system. It's very fun. I absolutely love it. So the challenge would be even more interesting if I installed TempleOS natively, right? So every time we'll have to restart the whole machine physically. That's a very interesting situation. All right, so I wonder, does it even have an opportunity to print anything? So what if I break after the first thing? So that is fine. Okay, so that is fine. All right. So maybe I just have to read through this entire thing because it's not particularly convenient to like crash every time or anything. So while n is greater than 0, while n is greater than 0. What's funny is that here, well, we don't increment that because that makes sense, actually. That makes a lot of sense. So it already crashes on the first sample thingy, right? So here is this first sample, which is rather interesting, right? So let's actually start debugging this like step by step. Step by step. So this entire thing is going to be just return version. Right, and in here we can do something like as operator. Okay. New line. Depth, double depth, and this entire thing. So we also chop that literal, so it's kind of obligatory to chop that literal, otherwise it's not gonna work. Wait, there's something about padding. Are they always padded or something? So, and these unlabeled 0 bits are extra due to the hexadecimal representation and should be ignored. Okay, so I think technically they're never going to be padded. I think they're packed pretty compactly, so I should not worry about that. For the operator, we might as well actually print the type of the operator. Because why not? Alright, so if I try to do something like this, right, it prints that it's an operator 2. Right, it's an operator 2. Okay. What did I don't know what I pressed. Something happened. Okay, so, and then let's take a look at the mode. Right, so it's going to be something like this, mode. D depth, and I'm gonna just provide it like this. Right, forgot a semicolon. So mode 1, right, so this is the mode 1, that means it goes in here. And in a mode 1, we have 11 bits, and it's a number representing the number of sub-packets immediately contained by packet. So that makes a lot of sense. And one of the things I'd like to do is probably just print that value, right? This is not what I want. So let me see. It's gonna be something like, it's kind of like a step debugging. It's kind of like that, but manual. It's a manual step debugging. S N D to depth N. Oh, right. So, and I actually didn't. Oh, okay. So maybe it's kind of pointless to try to like align them properly or something like that. So there is like only one in here. So after this one, it is going to be right. So it's gonna go in a pretty weird place, if I understand correctly, right? So, so let's try to kill that. There's only one afterwards. There's only one afterwards. And the question is, okay, so we're gonna actually now try to die in here. We're gonna return a version here. And I'm gonna do it like that. Maybe I wanted to keep it in here just in case. So it went okay, I think. Okay, so this is how deep we went. All right, so we had operator 2, operator 2. So that is very interesting. And at some point now we have a mod 0 with 11, mod 0 with 11. And it still didn't really crash that much. We can try to now see what's gonna happen in the literal. But in the literal, it's already... Yeah, this is gonna just basically crash the whole thing. Wouldn't it? I think it will. Well, okay. So, yeah, it's just like going forever or something like that. It's kind of weird. So I probably... Yeah, I see what's going on now, more or less. So one of the things probably we want to do, maybe I want to handle that thing manually, right, without actually trying to parse or anything. Right, so let's actually do something like print beats, and then a new line. Right, just to see what's going on. Thank you so much. Don't want to parse it manually, it's kind of boring. It's kind of boring, don't want to do that. Come on. Okay. So beats chop literal. When I chop the literal, right. When I chop the literal, I do that thing. Right, I do that thing. I see. Fuck. Can you spot the problem? Just a second. I wanna make a small break and cry a little bit. Okay, so I cried a little bit. Everything's fine. So let me actually double check if I don't have a similar problem anywhere else. Okay, chop left count. We pass it by a pointer, so I increment it like that. Then this is another pointer. I just pass it like that. And everything should be more or less okay. So if I try to run it one more time, hopefully. So that's kind of an important thing in here. So count is actually 0. Oh, and also, I made a very silly mistake in here. Yet again, you have to allocate this variable at the beginning of the function. For whatever reason, I don't know why. There we go. Finally. It was not even my... Well, it was technically my fault, but the compiler did nothing to correct me. The compiler did literally nothing to correct me. Thank you very much, compiler. Very cool. All right. So, and at least we can see the hierarchy. The hierarchy is actually kind of cool. So let me see. So I want to also try maybe to have like controlled amount of these things, if you know what I'm talking about. So I can do for I equals 0 and I less than 1 and this thing. And this plus I. Right, so this is the 1. So if I want to have 2 of them, all right, if I want to have 2 of them, I'm not going to have them for whatever reason. Why it didn't work? Because I forgot to remove the break. Thank you so much. Cool. So this is the second one, and the size of the second one is, I hope it is correct, it is 12. All right, so I'm super happy. 16 and 12. So 16 and 12. So I want to just slowly add them. I don't know why. 23? Is it 23? It is in fact 23. And let's completely remove this entire stuff now. So it should give me now 31. Was it 31? Okay, so all of them are correct. All of them are more or less correct. So should I keep this sort of like a debug information? Because it's kind of fascinating, right? So yeah, it gives a lot of information about the structure of the packet. So this is actually really cool. I really like that. Holy fuck. This is very cool. Anyway, so let's go ahead and apply that finally to the actual input. Right, I'm gonna go down. The input is rather big. Right, I hope I didn't fuck it up. Right. Yes. So this is going to be kawaii desu. And let's do that on the actual input. So the actual structure of this thing is absolutely fucking huge. Look at that structure. So one of the things we probably don't want to do is print the bits, right? So let's take a look at the structure itself. So yeah, so it's operator 0 mode blah blah blah. So this is literal, another literal, and that's a lot of things in here. Would you look at that? That's a lot of things. Holy shit. Okay. Okay. So, and the part 1 is 920. Okay, so 920. First try. Okay, let me guess. Now here is the correspondence between the types of the operators and what the operations they do. Now go traverse this AST and evaluate the AST and give us the number after the evaluation of AST. So now that you have the structure of your transmitted decoded, you can calculate the value of expression it represents. Literal value type ID4 represents a single number as described above. The remaining type IDs are more interesting. Packets with type ID 0 are sum packets. Then the value of the sum of the values of their subpackets. If they only have a single subpacket, their value is the value of that subpacket. So 1 is a product, 2 is a minimum, 3 is a maximum, 5 is greater than, their value is 1. If the value of the first subpacket is greater than 1, otherwise there's 0. The subpacket always have exact 2 subpackets. Okay, cool. Packets with type ID 6 are less than packet, okay, and then equal to. This packets always have 2 of these things. Using these rules, you can now work out the values of the outermost packet in your bits transmission. Okay. You can now work out the value of the outermost packet. So these are the same as were in here. No, they're different actually. So, all right. What do you get if you evaluate the expression represented by your hexadecimal encoded bits transmission? Cool. Let's go ahead and implement it, I suppose. So let me see. Here I return the versione, right? I return the versione. And I'm thinking it would be kind of nice to actually reuse the same thing in here, right? Just literally reuse the same thing. But that will require removing the version calculation, right? So what we can do in here maybe is now also accept the version sum, verse sum, like so. And it's also going to be like a reference. And as you iterate through this entire stuff, it just like adds those versions for you, right? It adds those versions for you. And the actual result in here is going to be the value it calculates, right? So let's actually do it like that. So, and this one is going to be maybe versum plus, right? And you have to dereference this entire thing, of course. So this is the versum, this is the type, this is mod, blah, blah, blah. So I'll actually do it like that. I64. So let's do a little bit of a refactoring. Okay, so and this is going to be type. And I want to remove this thing. Okay, cool. So this one is not particularly needed, I think. Right, and this one is also not needed. Now, when I do version, we just like append this thing to versum, though not really. Right, because I can just like do it like that. Versum. And this one is going to be also versum. Versum. Oh man, this one will require even more refactoring than I expected. Right, because yeah, different modes and shit like that is gonna be kind of painful. So maybe I should keep it as it was, right, and just like create a different one. I think I should actually, yeah, maybe. I'm not sure. Do I really want to like cram everything together? Do I really want to do that? Do I really want to do that? Maybe I do. Yes, I do. I made my mind. I do want to cram everything together. That's fine. Cramming the code is fine. Who cares about maintainability of a throwaway code? Oh, and by the way, you should not take it by a pointer because it's already pointer and TempleOS is not going to tell you anyway. So, and in here I don't have to do this stuff. So this is gonna be versum. So in here we can return something like 69 probably, right? So the actual value. And in here I'm going to do I64. So essentially we can compute part 1 and part 2 simultaneously, right? So because of that I probably want to get rid of this thing. So this is going to be just main, and this one is going to be just that. And in here we're going to have something like just main. Okay, so we have a count. Then I'm going to have versum, and probably the actual value, right? So we start with a count, versum equal to 0, right? So we provide the versum in here. Okay, and we want to compute the value. All right, we want to compute the value like so. This is not what I wanted. Like, what the hell has happened? So, okay. Beats chop packet. Beats count versum. Depth is fine. So this is gonna be part 1. So versum, and the part 2 is going to be the value that we computed. So that's basically going to be the idea. If I try to run that, so the part 1 is 920 and the part 2 is 69 because it's not implemented yet. Okay, cool. Very, very cool. Very, very cool. So let me maybe allocate the another variable like value of some sort, right? So this is going to be the value. And in here, I'm gonna just like sneakily. Why did it? Wait a second. Oh, okay. So it's a literal. I thought we're calling the chop packet, and I was worrying why don't I have a versum in here, but it doesn't have a versum, so it's fine. It is totally fine. Okay. So and in here is going to be value equal to that, and then we just return the value, right? We just return the value. Okay, and different modes make this shit a bit annoying, not gonna lie. Because now, depending on different modes, right, depending on different modes, you'll have to do that shit slightly differently. Oh my god, this is so annoying. Okay. Though, in both of the modes, right, we can notice a very interesting thing in both of the modes. And that thing is that we're just doing count and n-1 differently depending on the mode. So one thing we can do now is probably merge together these two branches, right? So we want to merge together these two branches. So if I try to run this, so part 2 is going to contain garbage. That is fine, unless we initialize it with something nice. I didn't want to do that. I wanted to press F5. Okay, so that is cool. That is cool. So the first thing I want to do, I want to just merge these things. So to merge these things, I basically need to, you know, assign n differently. So what's going to be the easiest way to do that? Like, I think there is no ternary operator in TempleOS. I'm pretty sure about that. So I can just safely assume something like this, 0. And do chop 15, right? So it's going to be something like that. Do chop 15, so this is going to be like this. It's a very annoying way of compressing everything, but it might work. It might work, believe it or not. Okay, so and then we share the same line in both of the branches, so we can quite easily just put it in here. So there we go. So we already compressed these two branches a little bit, right? So, and everything seems to be working so far. Cool. Interestingly enough, so the for loop is pretty much the same. So we can kind of try to move that for loop outside. Right, so we're moving it outside. I don't know why I did that, but it's fine. Right, so, and I can remove this thing. So now we're just having this stuff. But probably I want to do it like this. Okay, so this is that, and then this is that, and this is that. Cool. I just like got used to text editor reformatting all of that for me, so yeah. Okay, cool. Maybe since we use M only in one branch, we can basically initialize it only here, so it doesn't really matter. We can always initialize it here, which brings us to a very interesting point in here, right? Which brings us to a very interesting point. What if we always do this thing, right? What if we always do this thing and always do this thing at the end of the stuff? I'm losing the ability to speak proper English, I'm sorry. But now, look at that. We compressed everything pretty much perfectly, I think. Right, so yeah. So, and now we don't really care what's the mode, right? So here we have the value, we receive the value for this thing, and it just like simply doesn't matter, right? So that's the way we can now work with these things, and everything seems to be working. So we compress these two things. Now, depending on the type of the operator, right? The type of the operator, type, mode, blah, blah, blah. All right, so the sum should be pretty easy, I think. So let's go. Switch the type. Right, so this is going to be something like this. So how many operators do we have in there? Let me see, I already missed everything. Where is my stuff? So we have 8 operators, 0, 1, 2, 3, 5, 6, 7. So let's actually initialize all of them. Case 0, right. Break. 1, 2, 3, 1, 2, 3. Actually, there is 8 of them, right? So that means another 2. And there we go. Cool. So this is going to be 1, 2. Terry, why the fuck are you doing that to me? Okay, so this has to be actually 0. 1, 2, 3, 4, 5, 6, 7. And maybe for the default one, we want to scream that we have some sort of unknown operator. Unknown operator D. And I'm gonna go in here, right? So, and I'm gonna put it like that. There we go, hopefully. So, in case of 0, now what? Now what? I'm gonna assign like a value 0 in here. It's kind of weird. So let's actually put -1 as an indication that we have not figured out what that thing is, though we can put -1 in here. In fact, it's fine. All right, in fact, it is fine, so we don't have to do that in here. So now, if it is 0, this is the sum, right? So this is the sum, and we need to save that value somewhere. So this entire value should be probably called something like a result. Let me actually rename the value to result. Value, result, replace in the selection, boom, 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 boom. Cool. How can I unselect everything? I wish there was a way to quickly unselect everything, but I don't know the way to do that. Okay. So, and as the value, I want to have a separate variable in here, right? So we're going to store the value somewhere here. So here is the value. Okay, so, and interestingly enough, right, if result is less than 0, that means it was never initialized, right? That is very interesting, right? So because the packet with the type 0 are some packets, blah, 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 equal to this packets now have exactly 2 packets. So yeah, we can do a pretty cool thing. Essentially, if result is less than 0, it is less than 0, we are simply setting result to the value. So as an indication that this is, okay, this is the first operator, and for all of those things, it's going to be the same, right? So you just set that thing to the value. Otherwise, we do this switch. Right, I wish I could just quickly do that for all of these things. Okay, this is really, really painful. Terry, why do you force me to do this shit? Why don't you have an auto formatter? Maybe it does have an auto formatter, but it's just like, oh my god. This is the most painful text editor I have to work with in my entire life. But the text editor does not make you a better programmer, but it can certainly make you a worse one. All right, definitely doesn't make you a better programmer, but makes you a worse one. The wrong text editor makes you the worst editor, the worst programmer. Anyway, so for the 0, we essentially do plus value, right? For the product, the result of multiplication. If they only have a single value, do they ever have a situation when they... It doesn't matter, so we'll probably notice that. I thought maybe there is a situation when they have 0 of these things. So this is the product, right? So sum product, right? Sum product, minimum, maximum. Their value is the minimum of the values of the... Okay, so this is the minimum, right? So 2 is a minimum, 3 is a maximum. So I want to retype those things so I don't have to look it up all the time. Greater than, so the value is 1 if the value is the first packet is greater than. Okay, these packets always have exactly 2 sub-packets. Cool. Right, 4 is... Wait, what the hell is this debate? Oh, 4 is the literal. Okay, so I almost got debated. Almost got debated. 7, and because of that, okay, I see, almost got debated. So, advent of reading. Why are you open? What the hell is going on? Oh my god, okay, you slip up a little bit and your temple OS goes haywire completely. It's just like does weird shit. Okay, we're almost there. I just need to retype this entire thing. Okay. Case 0, 1. Why are you doing that to me? Okay, 1, 2, 3. 1, 2, 3, right? So, and essentially we're gonna have something like 2, 3, 4, 5, 6, 7, right? So, and in here we're gonna do something like break, right? And then the default is gonna be essentially unknown operator, D. Right, maybe like a couple of these things, and we're going to use like a type in here. There we go. And this one is the sum, right? So this one is the sum. Product. I think minimum and maximum, right? So this is another thing, minimum and maximum. For the 5, it's a greater than. For the other thing, it's a less than, and for this thing, it's going to be equal to, right? So it's equal to. So did I set the result? I don't even have, I lost so much. It's insane. It is insane how much progress I just lost due to a stupid Temple OS text editor. It's just fucking insane. Holy shit. Okay. So here's the sum, and in here I want to do something like if result is less than 0, that means the result is just equal to value, right? And luckily here I can just do quite easily something like this, right? And I don't have to worry about any of this shit. And cool thing about this text editor is that I can do something like this. Okay, that is very, very cool. So in terms of a sum, right, so what we do here is just like we add the value, then I multiply by this thing, then minimum is going to be minimum I64 between the result and the value. The maximum is going to be just the maximum, right, and in here, greater than, I can just do something like greater than. I think it's a greater than, then, is this greater than? Yes, it has to be without the equals. Then less than, and then equal to. Right, so this is how we're gonna do all of these things. Thank you so much, Terry, very cool. You've made a very cool text editor, I really appreciate that. Anyway, so AoC 2021. I'm using this editor for 2 weeks. 2 weeks! And it's still uncomfortable, like really, really bad. Okay, so cool. I want to double check one thing actually before I go, because I'm not sure if it's gonna like work properly. So if I have something like 69 less than 420, is it gonna be 1 if I try to interpret it as the number? Though it doesn't really tell me. So we have a like 83 something something semicolon. Okay, so it is in fact 1, right? So, and if it's not true, it should be 0. Okay, so I can kind of rely on this kind of thing. That is very cool. Thank you so much. All right, so let's actually take a look at the samples, right? So let's take a look at the samples, and I wonder if the samples are going to be useful for anything. So yeah, we have some values, but I'm not sure if these are the correct values or even useful values. So let me see, because I need to replace the samples, right? So I need to replace the samples. These samples are completely different. But I may maybe copy paste some of this. Copy pasting is not very convenient. So let's mount AoC 2021, right? And start my trusty text editor. Okay, so AoC MNT home AoC 16. This is the sample. Maybe I need to create another sample, sample2 txt, and let's copy paste all of these things in here. Of course, they are arranged, so you have to copy paste them one by one. Very convenient. Author of this problem, thank you so much. I really appreciate that. Okay, so this is going to be something like this. And let me see. So produces 1 because 1 plus 3 equal 2 multiply. Okay, so that makes sense, more or less. Though some of these things... Why this thing is highlighted, but some of them are not highlighted? It's just like kind of weird, but okay, that's fine. That's totally fine. Let me close this thing. Let me close everything, just everything. Run AoC 2021. Okay. So I kind of want to be able to disable the logging of the structure quite easily, but I don't think I can do that easily, right? So because it's pretty invasive in some sense, so I can only do something like this, I suppose. Though I guess, yeah, so the login is not really needed, right? So it served its purpose. Now we don't need that. So let me take a look. So this is a sample 2. I'm going to put the cursor here so it doesn't generate some garbage in the middle of the input. Thank you so much, TempleOS. I really appreciate that. And let's do sample 2. Let's take a look. So part 1, part 2, something is completely incorrect in here, by the way. Something is completely incorrect. So let's take a look at the part 2. All right, so the first one, resulting the value 3. So as you can see, it is not correct at all whatsoever, which is interesting. So result is -1, and in case of Oh, I know what's going on. I forgot to assign the value in here, of course. 354 and blah blah blah, something like 001. That looks correct, actually. That looks very much correct. I really like that. And let's actually check on the input. And holy shit, that looks sus. But okay. Though on the sample it does look correct. Let me disable. Let me double check everything because I'm really paranoid. 354, 79799100 everything seems to be correct. Less than equal to 4 is the string literal. Okay, so I think I need to make the leap of faith, right, and believe in myself. Right, just believe in myself, and just like, you know, submit this entire thing finally. I don't know what the fuck is going on. Okay. Output. None of the behavior of like selection or anything that makes any freaking sense. It's just like so painful. Okay, 1112. Let me double check. It's a 1112. Okay, okay. So let's close this entire thing. So mount AoC 2021. All right. So programming, sorting, AoC MNT home 16. Output. All right. So at what cost? God. Well, yeah, it's fine, I guess. It's an interesting problem, but TempleOS made it unreasonably difficult to solve, right? So in this problem, you just like have a lot of implementation details, right? A lot of implementation details. And because of that, you need to be very flexible in terms of how you refactor the code. And the text editor of TempleOS is not refactor friendly. It is not refactor friendly. Whatever you wrote in the text editor of TempleOS, it is set in stone. That said, you better not fucking touch it because it is very difficult to modify the structure of the code. And on top of that, there is no type checker which will check that now you're, instead of value, passing by a pointer, so you will confuse values and pointers, and your entire thing is going to Stack Overflow. So yeah. That's the challenges, but we managed to do that anyway. So yeah, you can find the source code of everything in the description, and I gotta go. Thanks everyone for watching. Love you.